Hello viewers, in today's session we are going to discuss an important problem from limits, and here we have to evaluate this limit involving the fractional part function. So here we have to find out limit x tends to 5 by 2 negative. Here negative shows that we have to find out the left hand limit of this function, that is fractional part of 2x, right? So let us see how we can easily find out the value of this limit using the definition of fractional part function. Now the fractional part function is defined like this, that is fractional part of p is given by p minus greatest integer of p, right? So we'll apply this definition to simplify fractional part of 2x. So fractional part of 2x can be written as 2x minus greatest integer of 2x. So replacing p by 2x. So now let us call this limit as L. So L is now limit x tends to 5 by 2, and here we have the negative sign, shows that we have to find out the left hand limit. So now a fractional part of 2x can be written as 2x minus greatest integer of 2x, right? Okay, now x approaches to 5 by 2 from the left of 5 over 2. So let us substitute x is equal to 5 over 2 minus h, and this quantity h is a positive quantity and it is infinitesimally very small. So when x tends to 5 by 2, then h tends to 0. So let us replace x by 5 by 2 minus h, and x tending to 5 by 2 negative, we can replace it by h tending to 0. So now we can express this limit in terms of h, and remember this h is infinitesimally very small, right? And it is a positive quantity which lies between 0 and 1. So we have now limit h tends to 0, and here we have 2 times 5 by 2 minus h, and then we can now write here greatest integer of 2 times 5 over 2 minus h, and here we have the brackets. So these brackets are simple square brackets, but here this bracket indicates the greatest integer function. So now we have limit h tends to 0. So here we can simplify. This is 5, 2 and 2 get cancelled, then we have minus 2h, and then we have greatest integer of 5 minus 2h, right? So now we have to assign value to this greatest integer, that is greatest integer of 5 minus 2h. So for this we'll make use of this inequality. Now see, h lies between 0 and 1, and h is very small. So 2h also lies between 0 and 1. Now if we multiply this inequality throughout by minus 1, then we have here 0, then we have minus 2h, and then we have minus 1. But the direction of the inequality, it gets reversed, right? So now here we have 5 minus 2h, so let us add throughout 5. So here we have 0 plus 5, and then we have 5 minus 2h, and then we have minus 1 plus 5. So now here we have 5, and then we have 5 minus 2h, and 5 minus 1 is 4. So we can also rewrite this inequality as 5 minus 2h is greater than 4, but it is less than 5. right? So now 5 minus 2h, it lies somewhere between 4 and 5. So the greatest integer of 5 minus 2h should be equal to this number, that is 4, due to the definition of greatest integer function. So now we have limit h tends to 0. Here we have 5 minus 2h, and then greatest integer of 5 minus 2h is equal to 4. And remember, whenever we come across with functions like greatest integer function, we cannot directly substitute h tending to 0, that is h is equal to 0, right? So we have to first see the value of this number, that is 5 minus 2h, which lies between any two integers, right? So here greatest integer of 5 minus 2h is 4, because this quantity, it lies between these two integers, 4 and 5, right? So now we have here 4, and now we can take h is equal to 0. So we have 5 minus 2 times 0 minus 4. So this is 5 minus 0 minus 4, that is simply equal to 1. So the left hand limit of a fractional part of 2x when x tends to 5 by 2, from the left of x is equal to 5 by 2, is equal to 1. So this is how, by the definition of a fractional part function in terms of greatest integer function, and using these concepts, we can easily find out the values of these kind of limits. So the value of this limit is equal to 1,